lo voy a hacer en inglés. Entonces, pues, por favor, denle un fuerte aplauso a Envy Alex Epon. Okay, so Ambi has a master's degree in software engineering and is currently enrolled in the PhD program at the Computer Research Center, working with Professor Gregory and Ildar. His main work is on enhancing machine learning and deep learning models on synthetic and semantic understanding using techniques that requires less resources. By doing so, he combines rule-based approaches with efficient learning techniques that take advantage of limited resource, but at the same time not impacting drastically the understanding performance of machines on NLP tasks. His main task is focused on applying most of the techniques developed in argument mining. So, welcome, Ambi. You have around 50 minutes. So, go ahead. The place is yours.
Buenas tardes, everyone. My name is, as she said, Eponon Alex. And today we are going to talk about the role of semantics in natural language processing. So the work will be divided into different sections. We'll be talking about some basics of what is semantics in NLP, but also we'll talk about some models that use semantics, some tasks, but also some applications. And at the end of the day, we'll be talking about some challenges that we are facing about semantics in natural language processing. So let's get started. So introductions. Why? Why are we here today to talk about semantics in NLP? Because as researchers or students, sometimes when we get started in natural language processing, we get lost. We get a bit disturbed by all those successes about ChatGPT, Claude, and everything like that. So we are asking ourselves, so where should we start it? It seems like everyone has done everything that is like the most valuable. But here we are going to talk about what is the most and really important is, of course, talk about that aspect in here. So first of all, before getting into everything, we have to talk about what is semantic, right? In our current life, when we are interacting with everyone, we understand languages, human languages, through our cognitive processes quite intuitively. We don't have any kind of logical process thinking like, oh, this is it, but it's kind of intuitive, right? But when we want our computers to understand the language, like the human language, of course, we have to tell it how to do that. And semantic basically is one way of doing that, is a way, a method to understand the human language, right? So at that moment, we have different ways to understand the human language. But here, particularly in semantics, there is a specific tool that we use to actually make computers to understand the human language, which is semantic. And this particular tool, I think you already know, it's the context. We all know what is context, right? I mean, vaguely somehow, but sometimes it's really difficult to actually define it. Because yes, it's really difficult to understand what is context because it's a complex thing. But for machines, precisely in natural language processing, we can just break it down into two things. When we have, for example, a sentence, it's about the position of the word, but how that word relates to all the words in that particular sentence. Basically, that's what it is when we are talking about a context in semantics or in natural language processing. And if you don't understand it, that's some examples, for example. The first one is the dog is swimming in the swimming pool. And the next one is he had dug under the branch. Okay, the first point here is that we say context is about the position of a word, right? Let's say the word duck in those two sentences. It's the same word, right? And the position here is that it is preceded by the article der in the first sentence, which tells us that, okay, that word is a noun. Because in English, most of the noun are preceded by an article, der, a, or an, or something like this. And the second, it is preceded by to, which means that this word now is not a noun, but it looks like a verb now. And so that's the same, sorry, the position of that particular word give us the nature, give us one actually information about the words, right? So after that, we have how that particular word relates to the others. Let's say the first sentence. The, the word duck, particularly, is associated with the verb swimming and also pool. So this helps us actually infer the fact that we are talking about an animal, right? Swimming in the pool. But the next one, that particular word duck, which is preceded by the to, which is the verb, noun, is actually associated with under and the branch. So now we think now about an action right now. That action of avoiding, particularly a branch, to not get it, right? So basically, this is what is context. Context, when we take those two elements, the position of a word and how it relates to other word in that particular sentence, it gives us basically the semantics, not only on the words, but also of the sentence particularly. And as I was saying, semantics is one way to understand basically the human language. And it's a kind of abstractions. And we have different abstractions, right? And here are actually two others, which are the syntactic abstractions and also the pragmatic abstractions. We have different ways actually. We have more, but we will focus actually on those two plus semantic. Now, before getting to what are the differences between syntactic, semantics, and pragmatics, I actually want to share you how I love seeing them, basically. For example, when we have a sentence, I love to see the syntactic aspect as the body, yeah, the body of a sentence, for example. Because when we have a sentence, we have different words which are linked by rules, right? They are all linked by rules. And it's like the body of the about the human body, right? We have the head, we have the neck, we have the stomach, the arm. And somehow, as human beings living on Earth, we are following the same patterns. I have not yet seen a human being having the head somewhere else except here, right? So there are some rules, and this is how we can refer syntactic. It's like the body of a sentence following some rules, and in language, it is just grammar rules, right? And then now we have semantics. How could we actually refer semantics? Semantics could be referred as, for example, the emotions of human beings. I have my own way of feeling things, you have your own way of feeling things. And now it becomes a mess, actually, because if I want to communicate with you, we have to agree somehow on how we have to deal with that. There's no rules. That's how predicting the semantics, the meaning of a word, becomes a bit complex than in the syntactics aspect, because there are not rules there. It's difficult for us to actually get the real sense of a particular word. And then, what makes actually this aspect difficult? Because actually, it can happen that because of my cultural background, because of my educational background, I convey my words differently, my emotions differently. And that's where pragmatics comes in. We can refer pragmatics as the intention behind conveying any kind of information or any sentence, for example. And this abstraction is much more complex. But today we will just focus on semantics. And let's say we have an example between the difference between syntactic and semantics. There is that example which is really actually famous, basically, which is the bank is by the river. Basically, this is a sentence where there is not any kind of action verb. So it makes actually the sentence a bit confusing and ambiguous, right? And that word bank could refer to different things at the same time, right? It could refer as this place where we actually get money, or we could relax, right? So how could we actually see the difference between syntactic and semantic? Syntactically speaking, this particular sentence is correct. It actually has a subject and a verb. So basically, there's no any problem, and also a complement, which is a river. So there's no any problem about the syntax here in that particular sentence, but the semantics is completely confusing. As I said, it's because we actually uh, don't have any action verb here. Let's say this example. She deposited the money at the bank. Because we have that action verb deposited, we will understand that the word bank basically is that institution, actually. And the next one is like, we said they had a picnic on the bank of the river. Because we see that had a picnic, we definitely understand that the bank here refers to that place where we can relax somehow. That's the difference actually when it comes to syntactic and semantic. Now, the difference between semantic and pragmatic, which is a bit actually a bit confusing, but let's say this sentence, oh great, another meeting, right? That particular sentence, semantically speaking, it's literally correct, basically. Oh, great. The person might actually feeling that he's really exciting about the fact that he will do another meeting. But pragmatically speaking, it means something else. Actually, it just means that the person is just annoying, exhausted that by another meeting, you understand what I mean? So pragmatically speaking is actually that intention that we want to convey through a particular sentence. And it can be completely at the opposite of the sense conveying by the semantics. And there's another sentence again, if you don't see it actually, oh sure, there is nothing more thrilling than reading 300 pages of technical documentation. If, for example, you are, let's say, a software engineer or software developer, you understand how it's so crazy to go through at least 20 pages of technical documentations. But here, semantically speaking, this sentence just showing that the person is just exciting by doing that. But pragmatically speaking, the person just wants to convey that this is annoying and this is boring, right? So that's the difference between how we can actually understand the human language at different level and how if we base ourselves on one aspect, we can get another sense, another meaning of that same particular sentence. And that's the particular difficulty of NLP, of natural language processing, of actually representing semantic in that particular field for machines, of course. And yes, then what is the place of semantics in NLP? Actually, if we want to talk about the place of semantics in NLP, we actually need to talk about one task, a very specific main task in NLP, which is machine translation. And this is actually going back, very back in the 1950s, where actually researchers tried to somehow, from one language, translate one language to another one. And actually, at that moment, they tried to do some, uh, try to apply, sorry, some techniques like rule-based techniques or ontologies where they try to match words by words. And they found out that it's extremely difficult because they were failing at that particular task. They saw that to be able to perform that particular task, they have to take into account not only the frequency of the word, but also the position of that word and how that particular word relates into that particular sentence, which is basically the context that I actually defined earlier. So that's why semantics is so important here, because it actually involves context, that particular context. So this is basically the love story, as I was saying, in between semantics and machine translation task. Because after that, researchers, started to build different kind of, methodologies like the LSA, latent semantic analysis, and with the rise of deep learning models, things became much more deeper in, in the translation. Sorry, in representing semantics, sorry. And later on, like more recently, we have BERT model, which originally basically was aiming at machine translation also. So now that we know a bit about how we try to understand the human language through machines, we need to understand that that particular understanding has different degrees, right? It has different degrees, and we can identify three main ones: the meaning, the sense, and the reference. So sometimes when you talk about meaning and sense, we actually use those two words interchangeably, but actually in semantics, they are completely different. For example, when we talk about meaning, it refers to a broad idea, a broad concept. For example, let's say I have a word play, and I go to the dictionary. That set of definitions about play is what constitutes meaning, the meaning of the words, right? And when we go basically to the sense is exactly one particular definition in that particular set of definitions. So sense, now to be able to get to the sense, we have to bring context in order to get the sense. I can take an example. For example, when talking with some friends, we can say, "Oh, this means something to me." So it's like we can recall it, right? But it's still a bit ambiguous to us, right? But when we say, "Oh, yes, that makes sense," it means to us that yes, this is clear. There is no any ambiguity into that. That's how we can see the difference between those two. And reference basically is a task where we actually try to refer things through, objects that exist in our world, for example. So, for example, when I say ESCOM, when I say SIG, I understand that what you are talking about because I know them. They exist for me. So, if I didn't know that, if they were not existing in my reality, for example, I would have not been able to understand you. So that's another level, basically, of understanding the human actually language. And next, actually, when we talk about sorry. Here we have, for example, an example that I wanted to show you is, let's say we are in physics and we say the morning star, the morning star. So the meaning here basically is that, yes, we are just talking about that celestial body in the sky, right? It's vague because we have a lot. We have planets, we have many things actually, comets and many things like that. But then when we talk about the sense, now the sense will tell us that it's actually that particular star that appears in the morning from Earth, which means that that particular star is visible from Earth in the morning, right? That's the sense. It gives us much more details about that particular star. And then when we talk about the reference, yeah, we know that, yes, that planet is Venus. And it refers basically to that planet that is visible in the morning. That's it. So that's how we can actually structure those three levels of actually 2 degrees of understanding the human language through semantics. And next, when we talk about the lexical semantics, we could definitely understand that it's about the meanings now of those particular words, like those set of definitions. And the compositional semantics is now how those meanings, those definitions combine themselves to give, at the end of the day, a full, global, and precisely um, sense of a sentence, for example. So here now, we are going to talk about the model. So now that we understand what is semantics, we want now our machines to understand the human language through semantics. So what we are going to do here is that we are now trying to represent semantics now at different level, of course. Here we can have at the word level, at the sentence level, at the document level, but we can go actually much more further than that at the idea level or at the concept level, at the sense level. It depends on the researchers and the task that they want to solve somehow. And here, when the researchers started to actually represent semantics for machines, they started actually to do some word embedding. It means at the word level, basically. I will not get into details. I will just go through it. And at the word embeddings, like word2vec or glove, what was happening is that they were just taking into account only the frequencies of the word into the corpus, or the corpora, right? They were not taking into account the context. So it was a bit limited. But furthermore, they understood that they need actually, in order to really, really represent the semantic of the human language, to embed the context. And that's where actually we got those contextual embedding. And yes, after that, they try also to particularly represent the semantic at the sentence level, but also at the document level, and so on. And then we got different kind of models, like the sentence birth, infer sentence, and we can find a lot on the internet, basically. So what are the different tasks that we can find in the I mean, we mean by task the different problem, the different skills that we want to give our machines, the abilities that we want to give to our machines. The first one, which is really famous in the field, is name entity recognition. If you remember, I was talking about references, right, as a degree of understanding. Here in that particular task, is like, let's say I give a sentence, sick is close to ESCOM. And we want the machine to identify the different entities in that particular sentence. We want the machine to understand that SIG is a laboratory, for example, and ESCOM is basically a university. So we want, that's particularly the task, to identify entities, and we have defined a lot of entities like persons, like organizations, and so on. We define ourselves. And then we have the task of sentiment analysis. I guess everyone here knows about it, where we try to actually identify if a text is just, let's say, negative, positive, or just neutral, like for reviews, for example. And we have word sentence ambiguation. This particular task is quite really interesting and complex because that's the whole idea actually of semantics. We want to actually reduce somehow the level of ambiguity of any kind of documents that we have. So that particular task is just about it. And then we have semantic role labeling. This particular task is quite really interesting because, for example, it deals sometimes with argument, for example. Let's say I give an argument. I say, mm, God created everything in humans. I am human, so God created me, right? So in that particular sentence, we have a conclusion and we have different premises. And we want our machine, for example, to identify what are the premises and what is the conclusion, for example. That's the basic idea somehow. And the next one is textual entailment. This particular task is very close to the previous one in a sense that given a set of sentences, we want to see how those sentences actually are logically related together and coherently. So for example, let's say in the previous example I took, we want, for example, to see how the premises are logically related to the conclusion. Are the premises supporting the conclusion or are in conflict, for example? That helps actually to really assess the level of understanding of machines. So that's really an interesting task for us actually to deal in. And of course, we can apply such kind of task when we are sure that our machine understands the human language to different applications. And we already know about the machine translation. And the information retrieval is just a task where we try to extract some information out of different documents because we know that in documents, not everything is so that important. And we just want to get the most important information given some queries, basically. And we have question answering systems and dialogue systems. Both are quite a bit similar because in the, let's say in the dialogue systems, it refers sometimes with chatbots, for example, and in the question answering systems is like given a questions to the machines, we want him to give it out back, for example, some precise answers somehow. And the challenges, yes, the challenges are really interesting. The first one is ambiguity. That's the mother of all the problems in semantics. We want all, as researchers and students, we want to reduce exactly the ambiguity of languages because as even human beings, it's really difficult when we talk to actually assess precisely what the person is saying. So for machine, it's much more difficult also to actually assess this problem. And even large language models also suffers from that. We have out of context, we have hallucinations, we have many things like that. So we actually are trying to find some solutions on how to deal with this particular problem. Some people actually proposes some solutions that maybe we know, like the RAGs, for example, which means retrieval augmented generation, basically. But even though we still have some issues in that particular problem. The next one is about reasoning capabilities. And this one is really interesting, actually. Why it's really interesting? Because since we started to actually get into AI, into that hype of AI, we actually analyze and observe different kind of, behaviors. And the first one was what we could call the system one and system two. Those particular system one and system two, paradigms called Daniel Kahneman. And he wrote a book and actually explained those two elements. What is the system one? The system one, as human being, is just the idea that we can give directly an answer extremely fast, right? If I say, for example, 1 plus 1, you will just tell me 2. You will not think that much. You'll be like, oh, that's really easy. It comes really fast, right? But the idea of the system two is completely different. If I tell you, okay, 100 times 15 plus 2 divided by 11, you know how to get the answer. for sure. But you have to break it down. You will have to go slowly, right? And then you will get the answer. So that's the system two. The system two is a bit rational, is a bit logical, and it's a bit slower, but it actually reason much more than the first system where we actually focus on the speed. Do you understand? So more and more actually researchers are actually focusing on the system two. That's why we will see that there are some researchers published where they talk about um, tree of thoughts, where they try to decompose, given a problem, they try to decompose that complex problem into smaller and let the models actually reason about it to solve a particular problem. So those are really interesting challenges. A lot of researchers are working on that. And the next one, scalability and efficiency. This is also another really interesting aspect in semantic because in order to represent, the human language, we had to go through a lot of data sets, a lot of corpora, right? And now, basically, we want to balance this, the computational resources and the performances. And if you really don't understand this, I have some cases that I actually found. The first one, for example, is the Microsoft case. During one report, actually, they say that during the 2021 and 2022, the water consumptions reached actually 2,500 Olympic-sized swimming pool. Maybe it's a bit blurry, but that's a calculation. One Olympic-sized swimming pool is about 2.5 million liters of water, right? So 2,500 will give us around 6.25 billions of water only for 1 year. And let's say in America and USA, basically a family of 4 persons consume 400 gallons. So I tried to make some calculation basically, and it represents around 11,000 families who consume actually of water consumption for 1 year only. Do you understand? And that was for actually the year of 2021. And that was at the moment where most of the model were not that at the multimodal capabilities. It means that they were just focusing on the textual aspect. But right now we have ChatGPT. We can access, for example, text, audio, and video, and so on. So it consumes more. This is about only the water. There is the production of CO2, carbons, and there is also the consumption of energy too. So those are really big issues, actually. And when you take another case, the OpenAI case, in the 2023 report, the same report, they actually say that from 5 to 50 prompts, ChatGPT consumed around 500 millimeters of water, basically. So I did again some calculations, and it was giving around 36,000 of waters actually consumption, just only for prompts. Only for prompts. We are not talking about training the models. We are not talking about those development phases, right? It's just about the prompt for that particular year of 2023. And that was a moment where ChatGPT released the ChatGPT 4.0 and ChatGPT 4. So we still have a lot of actually issues in terms of sustainability. So there are a lot of things that we can tackle as researchers or as students in NLP and semantics and how we want to actually represent the human language in a sustainable way. And yeah, now we just went through the basics and the introductions of what is semantics and basically the role of it. We just saw that semantics basically is just one way to represent and to understand the human language through computers. And we saw that basically we can represent that particular understanding through, at the word level, at the sentence level, at the document level, and so on. We can name it. And then we know that it could help us solve some issues, some tasks, like information retrieval and semantic role labeling, for example. But yes, we still have a lot of things to do in semantics at different level, basically. So that's what a very small introduction about semantics in NLP. And thank you very much. If you have any questions, any suggestions, comments, anything, we are here for that.
Thank you, Ambi. Okay, does anyone want to ask a question? Please.
Yeah, thanks so much for your presentation. I have a little bit question about your uh, um, review about semantics, because we know that ChatGPT is one of the most capability models in LLMs. But if we are thinking about to make models more sustainable the for the capabilities about water, for example, what is your point of view about what semantics could do for do a better work in this task? I mean, we know that ChatGPT is about millions or billions of parameters just to work. But how semantics could reduce these millions or billions, the parameters, just to be more ecological model?
Yes. Yeah, that's a really nice question. Thank you. Thank you very much. And yes, how semantics can actually help in actually solving the issues of sustainability when it comes to water consumptions and like wasting and everything like this. Actually, everything is in the process of representing semantics. Do you understand? It's like for for getting ChatGPT to have such kind of capabilities to understand the human language, we had to go through, as they said, the internet, right? And people actually argue that do we really need all the internet in order to represent the semantics of the human language? So the idea now is to find ways, because since we are mapping how human beings are actually learning the language and everything, the idea now is to actually see how could we actually uh, represent model semantics using smaller data, but quality ones, of course, because we know that we don't need everything on the internet. That's why, for example, we have sometimes the model saying very, very bad things, right? So we definitely know that uh, we have to basically see at the beginning of the step what kind of data do we really need? Do you understand? And position, if you want, such kind of policy in order to select exactly what we need in order to somehow represent perfectly, not perfectly, but approximately perfectly, the semantics, and then by so doing, reduce the training, the computational resources involved in that particular training. Now, so that's how it relates to semantics. Because all actually, ChatGPT is doing what it's doing just because he understands the human language. And that understanding is just about semantics, as we were talking about. So everything is just turning around semantics now. Semantics. So how do we what are the different methods are we using right now, and how can we improve them so that we will be able to use lesser and lesser data, but at the same time balancing the performance, like keeping the same pace. For example, like even yesterday and that week, Mistral and Apple and I think another company released some smaller models than before, because they actually know that most of the models now are actually really, really, really wasting a lot of energies and are being really harmful for the environment, for example. So it's a really hot topic actually right now. Thank you.
Thank you.
Hello, you talked about semantics. Do you think that is there a way to create like a model to help understanding the semantics, or is it just a human task?
Can you?
That if you believe that to understand better semantics, is there a way to create a model, a neural network, to understand the semantics, or do you think that it is just a human task?
Oh, okay. I believe modeling completely and perfectly the human language is extremely difficult because I was talking a bit with my supervisor and he said language itself is a manifestation of intelligence. So if you are able definitely to model basically the human language, you definitely solve the issue somehow a bit of what is intelligence in the human. You do understand? So it's a tricky problem, right? But yet, we are there for that. Do you understand? So we need and we should find better and better solutions on how we could represent the semantics, not only by human, because we are so, how can I say, biased somehow, but machines has this particularity to be transparent. Do you understand? So if we are able to build or to represent semantics, it would be actually helpful for us. But I believe that yes, it's possible. Not completely perfect, but we can reach a good level where we will feel satisfied somehow. So it's possible through neural network, of course, but we never know actually. Maybe some people will come out with beautiful ideas and it will work out. So it actually depends on how we will match our understanding, of human language and how we will model it through our understanding of cognitive science and everything like this. So yeah, it's possible. Thank you.
No sé si tenemos tiempo.
When you talk about System 2 and System 1, the System
See.
2 really catch my attention.
Okay.
So I wanted to ask you if you have heard about an implementation of this System 2.
The implementation of the system too.
Yes, or is only theoretical?
Okay. Good question. Thank you very much. Actually, the implementation of system two, there are actually some researchers basically working on that. And even, yes, there are some papers, but it's actually a new, actually, uh, endeavor. Do you understand? So the papers are new, and very few people actually mention directly the system too. But if you have already heard about chain of thought or tree of thought, those are different elements that people are trying to match with the system too, basically, somehow. Do you understand? So it's a new endeavor, but there are a lot of work to do in that particular, direction. Do you understand? So yeah, we hope that this particular route will, I mean, lead to reasoning capabilities for machines. But yet there are some actually implementations right now. People are trying to do some work in that.
Thanks.
Welcome.
Hay una pregunta más online. Ahorita procedemos a leerlo.
Okay.
Mercedes Bustamante asks, could you please provide an example concerning pragmatics and language machine?
I don't understand.
Okay. Could you please provide an example concerning pragmatics and language machine?
An example of pragmatics in language, in machine learning, right? Language machine. Okay. I understand. Actually, what is really actually interesting when it comes to pragmatics is that while we were trying to train models, on semantics, like to represent semantics, it had it had some kind of indirect consequences. Do you understand? Because we actually trained the model on semantics, it somehow indirectly got some ideas, not completely, but some ideas of what be pragmatics. So the examples I took in the slides um, about the two sentences was two sentences about sarcasm and about particularly pragmatics. And if you are in the field of NLP, you know that there are different tasks, different work, where we try to actually identify jokes, memes, or sarcasm, or such kind of informations. And those actually elements are just related to pragmatics, actually. So if you really want to dig into pragmatics, you should definitely go into that particular directions where we are talking about sarcasm or sarcasm detections or meme identification or something like this, because there are those different tasks where you could definitely, make use of pragmatics.
Thank you for your presentation. It was very interesting and pretty interesting. Really.
Thank you.
And my question is related to the task that you mentioned it
Okay.
in your presentation. For
Okay.
example, namely entity recognition, word disambiguation, and others.
See.
And my question is related in what of those tasks had advances has been done or had provided more advancements.
I don't understand the question.
In the case of semantics,
Okay,
in,
those
in
semantics.
which of those areas or tasks many advances have been done?
Many advances have been done in terms of semantics. Basically, okay, thank you very much. Thank you very much. I think I understand the question. Yes, in those particular, actually, those tasks which are here, we are trying to basically represent semantics for them to solve those problems, right? And of course, with the arrival of those large language models, all of those particular tasks got enhanced in terms of performances. Do you understand? So before we were using, for example, very shallow models or very traditional models to actually predict the name entity recognitions or even rule-based sometimes to do that. But now LLMs and everything, it seems like most of all those tasks reached the state of the art. For example, let's say if you take the example of Spacey or Stanford NLP, for example, most of those models for example, in name entity recognition can definitely get some really high score, like 97, 96 on terms of F1 score of accuracy, for example. And for sentiment analysis, some people even say that it's a solved task, like for the binary um, classification, like positive or negative, for example. But where it becomes really interesting is at that particular task of word sentence ambiguations, semantic role labeling, and textual entailment. Those particular tasks are really a bit complex because they involve a lot of, not only semantics, but also some kind of domain aspects, not general idea, but it really needs kind of precise, expertise. So that's why in semantic rule labeling, for example, we'll have a lot of difficulties doing some. For example, semantic rule labeling is sometimes related to argument mining. In that particular task, it's kind of a bit tricky because it mixes up a lot of things at the same time, and we have to actually sit back, reflect a lot, and try to find not just putting data and just giving some predictions, but have to go through a lot of reasoning. You understand? So the last three tasks are what are we could say the most actually not the, for me actually for me the most right now difficult somehow, and where we could actually try to do a lot of work for the future
Okay.
to bring more contributions.
Thank you. And I have another question.
Yes.
The second question is regarding about some suggestions to reduce the complex of, for example, ChatGPT or transformer models
See,
to make more on the efficient
okay.
the role of semantics.
Yes.
What are your suggestions?
Oh, my suggestions. I'm still looking for good actually methodologies, but the idea is I believe, and I'm not the only person about it, is that if we actually observe really those models like LLMs and everything, They are just good at inference, based on that probability distribution, they just infer. There is no any kind of um, reasoning, as we were saying, right? So now the idea is like, what kind of learning, basically? Like, try to go back. For me, that's the idea. That's how I see things. Let's just go back, right? And what kind of learning they were trying to implement? Because it comes from cognitive science, it comes from linguistics, it comes from even philosophy sometimes. So, what was the idea behind all those things? And we understand that when we go through the different kinds of learning, we understand that, for example, for ChatGPT LLMs, they mostly use the example learning. So it means that giving some examples, we try now to make some learning process, right? But it is not the only way of learning, basically. We have different, do you understand? We have, for example, the inductive learning, for example. We have the deductive learning. We have also the analogy learning. We have the instruction learning. The instruction learning is one learning actually. And sometimes in LLM, when we want to fine tune, we talk about instruction learning too, like just for fine tuning. But we have different paradigms when it comes to learning. And we want now to understand that which kind of learning and what kind of combinations of learning we could actually implement or build so that at the end of the day, we will use less data, right? And at the same time, keep the performance high. So that's how researcher could actually sit back and think about it, not just following the trends, the fashion, try to go back a bit. So that's the idea, I could say.
Interesting. Thank you.
Thank you.
Creo que por el tiempo ya no.
Okay, I'm sorry. Okay, thank you, Ambi. All the stuff you said were very interesting.
Thank you very much.
So here is your
Thank you.
something.
Thank you very much.
And we also prepared this for you.
Oh, thank you very much. Thank you.
Have a look.
So,
Ok, chicos, no se me vayan todavía. Tengo una serie de anuncios que hacer. Déjenme acuerdo. El primero, el taller de procesamiento del lenguaje natural, ya no va a ser en esta aula, se va a mover al sitio, en la sala E1. Para quienes no completaron su registro antes de la ponencia, los invitamos a la mesa de registro que está ahorita acá afuera para que puedan ponerle su asistencia si es que no la han registrado aún, ya que recuerden, necesitan el 80% de sus asistencias para obtener su constancia. Y me parece que son todos los anuncios. Gracias, pueden ir.